Alright class, this is number 45. So first rule of thumb is you want to change things to sines and cosines. Now this is where you really don't want to do that, and I know that because I've been working with these problems enough that when I see a squared symbol, I'm going to want to use the Pythagorean identities instead. So let's see how that works. Pythagorean identities, the one for 1 minus sine squared, I would use this, sine squared x plus cosine squared x equals 1. It's the first Pythagorean identity. So if I subtract sine squared from both sides, okay, I'm left with cosine squared equals 1 minus sine squared. 1 minus sine squared is what we have in the problem, so we know 1 minus sine squared is cosine squared. So instead of 1 minus sine squared, I'm going to put cosine squared. Alright, well what do we do with the bottom? Cosecant squared minus 1. Alright, well similarly, you can see in the last Pythagorean identity that 1 plus cotangent squared equals cosecant squared of an angle. If I subtract 1 from both sides, I find out that cotangent squared equals cosecant squared minus 1. So I'm left with cosine squared over cotangent squared. Okay, so I'll make some room here. Alright, so cosine squared over cotangent squared, I'm going to break them up. I'm going to write it as cosine squared over 1 times 1 over cotangent squared. This would equal cosine squared times tangent squared, because 1 over cotangent squared would be tangent squared. Alright, another step. I still have cosine squared. Now I'm going to change this to sines and cosines, and it turns out on page 372, tangent squared is sine squared over cosine squared. So what does this equal? Cosine squareds cancel. Sine squared. So we started out with this. We changed the top to this. We changed the bottom to this. We separated them. We changed this left side here, or the right side here, excuse me, to tangent squared, because 1 over cotangent squared is tangent squared. Then we changed tangent squared to sine squared over cosine squared. We kept the cosine squared here. And then we divided these out, and we were left with sine squared.